So let us see some examples using Python to implement mathematical morphology. So for any case in which we want to apply those techniques to process images, we have to first define a structuring element, which will define the shape of the of what we are going to match in the image. Slide or shift this element through the image, and then modify the image according to how the structuring element locally matches the pixels. I'm going to use those packages here, in particular Morphology from scikit-image, which is very handy in this case. So Morphology package contains the main structuring element shapes. The disk is one of the most widely used because it is smooth, so it has a smooth corners. And in the case of a small disk, it's the same as we define a diamond or even a cross. So we can note its difference when we change the value. So disk of 1 in the case of scikit-image means that we have 1 in each direction. So when you have 2, actually have a disk of size 5, because we have in here 2 and then 2 lines here. That's the idea. So you can see that this is also similar to the diamond. So when we increase it to 3, then it appears more like a disk or a circle. However, we can import other structuring elements as well, not only disk. We have the square, rectangle, diamond, disk, and the star. I already showed you the disk in 3 with value 3. Note that how it's different from diamond in this case. I'm going to define a vector of structuring elements, a square of 7, a rectangle 7 by 11, diamond of 7, disk of 7, and a star of 7. And then I'm going to show it. I'm going to use the color map paired for better visualization. So this is the square, the rectangle, the diamond, the disk, and the star. And we can also design our own structuring element. In this case, I designed the structuring element by defining a 0 matrix and then inserting 1 in specific directions. It is kind of a cross, however it's thinner on one side. Let us show it. So this is the structuring element I created. So let's now try some basic operators on an image. Let us take this image as an example. I'm working with binary images in this case. And the first operator is the erosion. So in this case, all local pixels of the image have to overlap those of the structuring element. It is related to the minimum filter, because if we consider that everything must be overlapped, and in the case of binary images, the minimum value should be 1 or 0. So if we have a filter, minimal filter, and we have a single 0, we will replace by 0. So that's the intuition behind it. I'm going to use 2 erosions with a disk of 1 and a disk of 7. So as we have seen in the previous video, with a disk of 7, the erosion is much more intense. Note how, in this case, we kept all elements of the original image. However, those are smaller, so they have been eroded. So the objects, all objects here, are smaller than in the previous one. However, with a disk of 7, we ended up by eliminating some of those objects, or even keeping them, but with a very small area right now. So erosion could be, for example, used for image segmentation by when we want to keep only the large objects, we can erode that image until only the large objects are left, and then we can use those elements in order to perform the segmentation of the image. In the case of dilation, at least one local pixel have to overlap those of the structuring element. So it is related to the maximum filter. That means we replace the value of a pixel by the maximum value covered by the structuring element. Note that when we are shifting the structuring element, if a single one is overlapped, then we get the maximum, which is 1, and then it produces the dilation. Let us see the same image and using the same structuring elements, but now with dilation. Clearly, what happens is that we are augmenting the objects and making them to have round corners because we use the disk, and then on the corners of the image we have with the overlap follows the shape of the image. Especially with a disk of 7, we can see this effect. If we substitute it, for example, with the square, we can note the effect is not the same. So in this case, we don't have round corners anymore. So the objects that have straight lines are kept that way. So straight lines are kept for all objects. However, it distorts objects that does not have this shape. For example, the circle here. It's kind of like it has. It was like it's not a circle anymore. It has some flat regions here along the object. And if we use a star, for example, then because the star has a specific shape, it doesn't match the exact star that is here because it is pointed to the top, not to the side or to diagonal as this one. Then everything becomes like has this star shape or this spiky shape in the corners. Let us see the effect of different structuring elements. So I'm going to define a cross here. I'm defining my own element, and then the disk, and then compare those two side by side. So this is the dilation by a disk, dilation by the cross, erosion by the disk, and erosion by the cross. So by defining different structuring elements and using dilation and erosion, we can achieve many image processing methods, as we are going to see in the next videos.